Okay, today then I'm going to finish, the analysis of 5 process. In order to refresh your memory, I'm going to briefly summarize we have investigated based on your problem sets as part of the first miscellaneous item. So connection should be made in mathematics classroom to help a student recognize use connection among mathematical ideas. But I emphasize this means the connecting idea in algebra and geometry. New and old ideas connection are representative in this category. The second level of connection understand how mathematical ideas interconnect and build on one another to produce a coherent whole. One of the important concepts in this category, you need to understand what is the meaning of producing a coherent whole. That means the same mathematical structure in seemingly different setting, which I emphasize based on the problem. And the third category of connection, recognize and apply mathematics in context outside of mathematics. In other words, other subjects, area and disciplines such as science, the social science, medicine, and commerce. I hope you understand better now what is the meaning of connection in terms of mathematical process. I hope based on this understanding, you may develop mathematical essay problem better. Another important, process, one of the NCTM 5 process, use of representation. Representation means use representation to organize, record, and communicate mathematical ideas. Right? This means both process and product should be considered. Another important thing you need to understand, naive and conventional representation in this category. The second category of representation, select, apply, and translate among mathematical representation to solve problem. Based on your problem, you suggested, I emphasized in order to translate among mathematical representation, students themselves, they need to develop multiple representation first, and then out of multiple representation, they need to understand what kind of strength, right? What kind of weakness for each representation. That is the basically second category of representation. The third category of representation, use representation to model and interpret physical, social, and mathematical phenomena. I emphasize 2 words, model and mathematical, in order to understand deeply this statement in the third category of representation. That means model means mathematical representation and relationship, use of variable to represent unknowns, devising representation such as equation, table, and graph that capture mathematical relationship should be included in this category. Make sense to you? So basically, I emphasize connection representation. And last time, I also explained, based on several problems you develop, the problem solving means should enable all students build new mathematical knowledge through problem solving and solve problem solving that arise in mathematics and other contexts. Let me explain once again the meaning of that. So, as you can see, building new knowledge through problem solving extension, right? Extension of knowledge. Also, you need to differentiate what is the meaning of problem versus exercise. And the second category, solve problem that arise in mathematics and in other contexts. I emphasize the word, the meaning of arise, right? That means the context of a problem should be worthwhile in their students' words and experiences. So arise is neither apply nor model. I explained last time. So the third category of problem solving, apply and adapt a variety of appropriate strategy to solve problem. So students need to categorize and compare different strategies. So in order to categorize any problem into this category, students basically need to develop different kind of strategy, right, in the same problem. That is one of the important things. But students also categorize and compare different strategy. That is the meaning of the adapt in this category. The third one, monitor and reflect on the process of mathematical problem solving. So monitor and adjust, that means the monitor and adjust their strategy. So that means including the metacognition in the process of problem solving. Do you understand better the three different process, connection, representation, problem solving? I hope so. So let me finish problem solving by comparing hierarchy. Take a look at some hierarchy. So group 6, in this category of problem solving, decide hierarchy like this way. First, building new mathematical knowledge through problem solving, first level of hierarchy. Second level of hierarchy, apply and adapt a variety of appropriate strategy to solve problem. Monitor and reflect on the process of mathematical problem solving. And the fourth, solve a problem that arises in mathematics and in other contexts. In contrast, group 10 decides in this order. The first level of hierarchy is the same, build a new mathematical knowledge. However, in group 10, they decide the second level of hierarchy in problem solving, solve problem that arise in mathematics and in other contexts. The third one, adapt and apply and adapt a variety of appropriate strategy to solve problem. The last one is metacognition part. Right? Can you see the differences? The group 6. Metacognition part, third one, right, in group 6. However, in group 10, metacognition part is the fourth one. Can you see the differences? This is group 6. Application part, as you can see, the first one, right? Group 10 in this way. Metacognition is the last one. In contrast, the application part in other contexts and as well as in mathematics is second level of hierarchy. Also, one of the important things you should understand in terms of using the category by using hierarchy, because based on this hierarchy, my assumption, you can decide based on the hierarchy which problem is more difficult than the other problem. Right? That's why this discussion is important. For instance, while you are making mathematical essay problem, which problem is more difficult than the other one? How can you decide? For instance, in the category of problem solving, probably in group 10, they may decide some metacognition problem is going to be the most difficult one. Right? Am I correct? Because this is the highest level of problem solving process. In contrast, group 6, the most difficult problem probably to group 6, some application problem, especially in other contexts, might be the most difficult problem. That's why the hierarchy in problem solving or in connection, in representation is so important, especially to teachers. because which one is, even though obviously there is clear result if you are going to finish your grading, right? Because maybe 10% of students are correct in this problem. It is the most difficult, right? But that's just the result. I'm talking about the process. Which mathematical thinking process is more difficult than the other? Even though some of the students may correct, right? However, because of some minor mistake, a lot of students make a minor mistake in solving that problem. That's why many students are incorrect in that problem. That's not going to be a good problem, because why many students made a mistake, right? Because many students made a mistake in that problem. That's why the correction rate is so low, right? Those kind of problem is not going to high level of problem. So I'm a little bit talking about hierarchy and then finalize the reasoning and proof. We can start your ping pong. I just want to hear your opinion about the group 6 and group 10's hierarchy, or even others. And then I'm going to finish hierarchy discussion. And maybe half of the class, I'm going to focus on reasoning and proof. Next class, I'm going to move toward the conceptual mapping. Today is going to be the last class in terms of explaining 5 classes. 32. Let's see how many students. 1, 2, 3, 4, 5, 44 students. We still have 7 students. 손 드세요. If you do have any problem, raise your hand. We're going to help you. Just in case. 빨리 들어오세요. 자, 43명이 되는데 일단 시작하도록 하겠습니다. Okay, you can see the question, right? Which one do you prefer? Do you understand the hierarchy, right? Group 6 and 10, or even others? You can start right here. and 6, group and 10 idea I'm going to show you once again. You will understand. Group 6, conclusion like that. Build new mathematical knowledge and adapt the variety of appropriate strategy and monitor, reflect, metacognition part. The last one is solve problem that arise in mathematics and other contexts. In contrast, group 10, this way. Build the mathematical knowledge, the same one, however, group 10 selected the solve math problem that arise in mathematics and in other contexts, second level. The third one, different kind of strategy. The fourth one, metacognition part. Now you understand, right? Okay, so I want to hear your opinion. So what do you think? Which one do you prefer? I'm not asking which one is correct, okay? And I'm asking you, if you're going to select one of them, I'm going to ask you why did you select that option? Students should be 36. Three more. 2. 안 되는 사람 있으면 손 들어주세요. 두 사람은 안 된 것 같은데. 안 되는 사람 좀. 됐어요 이제? 두 사람 다 됐어요? 됐어요? 다시 눌러줄게요. 한 분 됐고 한 분만 더 하시면 다 됐습니다. 오케이. 그룹 6개 맞네요. 24, 그룹 10, 15. 이 4는 뭐야? Who is 4 by the way? 또 잘못 눌렀다 그럴까요? 주영이 잘못 눌렀어요? 뭐 원래 뭐 누르고 싶었어요? 2번이요. 2번? 오케이. 2번이 그럼 한 명 더 많아지네요. 자, 먼저 others부터 한번 들어봅시다. others opinion. 신일승. 발표했어요 그때. 잠깐만요. 발표 안 하신 분 위주로, 왜냐면 다 한 번씩 발표하면 좋을 것 같아서 발표는 제가 유수히 발표 안 했는데. 유수히 발표 안 했어요. 아까 안 갖다 준 거. 좀 크게 말씀해 주세요. 안 들리니까. others라는 의미는 어떤 의미에서 했죠? 제가 다시 한번 보여줄게요. 그러면 이렇게. 그룹 10을 이렇게 결정했는데 NCTM 스탠다드의 순서대로 그룹 10을 결정했고요. 예. 육족도 같이요? 예. 이거 같이 보여주기가 육족하고 10족구를 같이 보여줄까요? 이거를 그럼 없애버리고 일순 학생 그러면 여기서 어떻게 오더가 어떻게 되면 더 이상적일 것 같아요? What do you think about the hierarchy level? Which one should be the change? And why do you think so? You don't have to discuss all the 4 processes, okay? You can just select one of them because I think this is not that easy to discuss all of them simultaneously. That's why you can emphasize just only one point in your mind. So which one do you want to change then? Compared to group 6 and group 10's level of hierarchy.
두 번째 단계에서 첫 번째 단계는 구조가 똑같고
예.
두 번째 단계에서
첫 번째, 두 번째 어느 그룹하고 똑같아요? 그룹 6 or 그룹 10?
첫 번째 단계가 구조가 같이
예.
그 다음에 그래서 두 번째 단계에서
두 번째 단계는 서로 다르죠, 그죠? 그룹 6는 어플리케이션을 선택했고요. 그룹 10은
거기서는 어플리케이션이 나을 것 같고 근데 그 다음 3번에서 6조하고 좀 다르게 수학과 다른 맥락에서 발생하는 문제들 그 다음에 마지막으로
메타코그니션.
네.
오케이. Let's hear the group 6 and group 10's opinion first, and then I'm going to ask others' opinion. What about group 6? Group 6, what is group 6? Okay, why don't you tell us why did you decide this level of hierarchy? Maybe that's going to be much more easier, right, for others to understand the level of hierarchy. Why don't you explain to us? Yes. Just speak loud.
우선 저희 조는
네.
저 순서가 하이어라키가 위에서부터 아래로 가는 게 점점 더 어려워진다는 그런 개념보다 그러니까 저희가 교과서를 택했는데 교과서에 나와 있는 그 순서 자체가 저 순서를 통해서 학생들이 그 학습을 하도록 나열이 되어 있었고
네.
그리고 사실 저 순서에서 끝나는 게 아니라 저희는 그 리커시브하게 계속 돌아가는 걸 원했거든요.
Can you explain more?
그러니까 마지막에서 이제 그러니까 반영적 사고를 한 다음에 이제 다른 분야에서나 다른 곳에서 그 어라이즈하는 그런 문제들을 푼다고 되어 있는데 풀고 나서 이제 그걸 통해서 또 다른 새로운 지식을 이제 습득을 하고 이런 식으로 계속 1, 2, 3, 4, 1, 2, 3, 4 이렇게 계속 가는 그런 걸 사실 원했거든요.
Basically, group 6 kind of what is it? This shape. Do you know this shape, right? What is it? All of a sudden, I cannot remember what kind of word can we use. 이 나선형 구조 있죠. 한국 코리안 이렇게 그죠? 1, 2, 3, 4 and 좀더 높아지면 어떻게 돼요? It's much more higher, a little bit more higher, but almost the same process is going on, right? Do you understand why? So group 6 emphasize that, but still in the same problem, you think this kind of order, right? So first of all, build new mathematical knowledge, right? It's kind of first level. Second one is different kind of strategy, right? And apply, adapt. And third, metacognition part, right? And fourth one, solve problem that arise in mathematics and in other contexts. Can you explain more about why the last one, this one is the highest level in the same problem?
아무래도 그 적용을 하고 그런 것을 하기 위해서는 수학적 개념을 완벽하게 이해를 해야지 가능하다고 보기 때문에
Application should be the highest level of understanding in the same situation, right? What about the group 10? Speak loud, please, to hear other students.
일단은 그 두 번째가 문제 여러
selected the third one, different kind of strategy in the third level. Can you tell us a little bit more? You just explained 1, 2, 4, right? So third one.
그러니까 먼저 첫 번째는 첫 번째 수학 지식을 정립하는 데는 생각이 필요 없을 것 같아요. 그래서 수학 정립된 수학 지식을 통해서 이제 바로 이렇게 어떻게 보면 자연적인 지식만 있으니까 다른 전략에서 모르잖아요. 그런 상태에서 지식인 상태에서 수학 말고 다른 상황 문제를 풀면 완전 이렇게 돌릴 수 있고 이렇게 돌릴 수 있구나 이런 식으로 해서 다른 문제를 풀은 다음에 다른 문제를 푸는 과정에서 그런 수학에 대한 여러 가지 문제에 대한 단순하게 알고 있는 A만 알고 있다면 그 다른 화학 문제를 풀어보면 A가 아니라 B, C 이런 다른 전략들을 알 수 있어서 그런 다른 전략들을 알게 된다면 그거를 다시 원래 알고 있었던 A가 푸시던 문제에 다시 풀 수 있으니까 그렇게 생각해서 그래서 다른 화학 문제를 풀어본 다음에 그 세 번째 문제 어디서 오프라인 뭐 그런 여러 가지 전략들을 이제 택하는 와중에서 이제 원래 A가 푸시던 문제, B, C 문제를 택하다 보면은 내가 원래 풀던 과정에서 뭔가 좀 실수한 부분이 있을 테고 이렇게 한 번 넘어갔을 때 내가 좀 돌아가는 그런 부분이 있을 테고 그런 과정을 통해서 문제의 과정을 검토하고 반영할 수 있다. 그래서 순서를 시작했습니다.
네. You understand the group 10's opinion? I think based on NCTM standard, that's exactly, I think, what NCTM standard emphasize. If you carefully read NCTM standard, they ordered in this way, right? Take a look at, for instance, take a look at the NCTM standard sequences, like this way. You know, right? Build, solve, and application, apply different strategy, and the first one, metacognition. The reason why they decide in this way, as you can see, you should understand the arise meaning, right? Probably some of you misunderstood the meaning of arise. Arise means, what is the meaning of that? I emphasize, right? Arise means problem should be based on what? Students' words and experiences. That means this is not that high level of problem. Okay? Because think about it. If you're going to teach any problem, right? Student can develop mathematical knowledge, new knowledge, right? What is the second level of problem set? You can develop some basic problem based on what? Students' words and experience. That's why NCTM standard maybe put this one is second level of hierarchy. And third one, obviously, after solving this kind of problems set, problems that arise in mathematics and in other contexts, they may develop different kind of strategy, right? And also select, as he explained, right? And then finally, metacognition is the highest level of understanding from NCTM standard. Anyway, so I just want to emphasize in each category, each process, the order have a meaning. Okay, it's not just randomly assigned. NCTM standard, I think, intentionally put this order. But you need to carefully read NCTM standards, and then you may better understand 5 process in depth from my perspective. That's why I have discussion time on this issue. Maybe other hierarchy level also, we don't have enough time to discuss all hierarchy you develop. But think about in depth each hierarchy level, okay, based on your developments. Any question? I hope you understand better. Any question you can ask. But I'm going to finish today the reasoning and proof. And then I'm going to start the next time conceptual mapping, which you submit as part of the second miscellaneous item. Okay, the last one, I think reasoning and proof only, I think, what is it? Group 3 worked on reasoning and proof. Probably this one is not that easy. That's why most of you focus on connection or representation problem solving. But anyway, I'm going to just briefly review group 3 work based on NCTM standard. According to the NCTM standard, reasoning and proof is another important process, right? Even though we have focused on connection, representation, problem solving, reasoning and proof is one of the most important things in mathematical thinking process. That's why reasoning and proof you should understand. But according to the NCTM standard, through emphasis on reasoning and proof in the classroom, all students will recognize reasoning and proof as fundamental aspects of mathematics and make and investigate mathematical conjecture, develop and evaluate mathematical arguments and proof. Select and use various type of reasoning and methods of proof. Let me explain in depth once again for your better understanding. Because you worked on reasoning and proof. First level of thing, recognize reasoning and proof as fundamental aspect of mathematics. What is the meaning of that? For instance, one good problem to represent this category, why by evidence? Why students need to realize, right? For instance, some elementary, even some middle school student, even number plus even numbers equal to even number. Why is that? But some student maybe tell me because my teacher told me, right? Instead of by evidence, they may reliable, right? They may depend on some other's opinion or other sources because textbook tells me. So I believe that. That's not going to be mathematical evidence, right? That's going to be problematic. That's why by evidence should be a good problem in this category. What about sources for reason? Once again, the same process, right? Why do you think so? If you are going to ask this kind of question to your student need to respond to your question what? Based on what? On the basis of some sources, right? But the source should be what? Mathematical reasoning. Instead of others' opinion or others' textbook sources or other newspaper or something, right? Make sense to you? This is the category why students recognize reasoning and proof as fundamental aspect of mathematics. Make sense to you? This basic category? That means reasoning and proof is a fundamental aspect of mathematics. Students need to recognize that statement. The second one, make and investigate mathematical conjecture. What kind of problem? So just after realizing reasoning and proof as a fundamental aspect of mathematics, they need to develop some informed guessing. For instance, case 1, case 2, case 3, what about case 10? What about case 100, right? This is basic reasoning, right? Because they kind of develop what? Inductive reasoning. Or is it true always? What change? Counterexample are good representative in this category. Make sense to you? Also develop and evaluate the mathematical argument and proof. This is just base level of reasoning. However, after finishing this kind of reasoning, they develop more rigorous way, right? For instance, why does this work? It's much more long kind of reasoning process, right? Instead of n is 1, n is 2, n is 10, n is 100, this is a part of reasoning. However, this kind of much more close to what? Discrete reasoning, right? But this one is much more what? Why does this work? It's a whole kind of reasoning, right? based on any statement, based on any mathematical fact. They need to work on whole process instead of just part of it, right? That's why this is a much more higher level. What about the extension to general cases? What about the generalization, right? What about, this is obviously much more higher than this one, right? Make sense to you? So anyway, you need to think about what is the meaning of develop and evaluate mathematical argument and proof. This is a good example according to the NCTM standard. I just want to provide a more concrete example for your better understanding. What about the first one? Select and use various type of reasoning and methods of proof. I emphasized many times. Use various type of reasoning and method of proof means they need to develop different kind of reasoning, right? In the same problem, not different problem, okay? So that's why norms for them or deductive argument should be in this category. This is very broad term. Various type of reasoning mean include deductive reasoning. Do you understand what is the deductive reasoning, right? It's very highest level of reasoning, right, in mathematics. That's why NCTM standard categorize 1, 2, 3, 4 different kind of hierarchy. Do you understand better, right? Let's take a look at then group 3 problem for your better understanding, and then we are going to have a discussion time. Let's look at first one, this one. What about this one? Group 3 developed 일반항이 AN equal 3N plus 4인 수열 AN은 등차 수열이 되는지 말하고 그 이유를 이야기해 보아라. 자, 수열에 관한 문제예요. Group 3 decided in sequences in their problem analysis. So, what do you think? This problem can be recognized reasoning and proof as fundamental aspect of mathematics, or make investigate mathematical conjecture. Or third one, develop, evaluate mathematical arguments and proof. Or the fourth one, select and use various type of reasoning and methods of proof. You can start now. 다시 한번 해볼게요. 빨리 누르세요. 더 많은 문제를 보기 위해서는 같이 좀 더 디스커션 많이 해보면 좀 더 이해를 더 하실 거예요. You need to select one of them. Former student, I think. 자, 빨리 하세요. You didn't decide yet? One more. Let's see. One. As you can see, group 3 categorized number 1. Let's see number 4 first. Let's select number 4. 이희주? Can Can you explain to us why did you select number 4? Let me go back to the problem to show you this one. 학생이 설명해 주실래요? 그냥 자기 리즈닝을 이야기해 주면 돼요. Right. I understand your point. But I emphasize many times, especially you need to focus on different kind of reasoning. So different kind of various type of reasoning and method of proof means problem itself should specifically ask that kind of question. In other words, for instance, in this problem, if I'm going to change this problem this way, 등차수열이 되는지 말하고 그 이유를 두 가지 서로 다른 그죠? 추론을 바탕으로 이야기하시오. 이러면은 이 4번이 맞아요. 이해하겠죠, 그죠? Do you understand my point? Okay? Problem in terms of developing assessment, you should specifically and concretely ask that kind of question. So in other words, if you want this problem categorized as this category, you should ask specifically. I understand those kind of possibility. Maybe some of the students develop one kind of reasoning, others develop the other kind of reasoning. Obviously that's true, because the justification may differ in the problem solving process. However, if you want to categorize the problem itself as this category, you should specifically ask that kind of question. In other words, for instance, one is inductive way, the other is deductive way. You need to justify this statement likewise. Make sense to you? Okay, so everyone understand the point, okay? Right? Why this problem cannot be the first one. Make sense now to you? Any question? Let me ask two. 그래서 재훈이 했고, 재훈이 했죠. 재훈아는 했지? 예. 1순위도 있고. 성룡이 했어요?
네.
했어요? 둘이 했니? 피하기 위해서 한 거 같은데 한 거 아니야? 잠깐만요. 저 보면 알죠. 아, 둘이 했구나. 엄다영, 다영이 됐고, 김규은 했어요? 규은 학생? 규은 학생 했구나. 막판은 임준혁, 준혁이 했어요? Why did you select number 2?
제가 약간 사실 잘못 생각한 게
예.
여기에서 메이크라는 메이크 앤 인베스티게이트라고 했으니까
예.
문제에서 가설을 학생들이 가설을 만들기를 유도한 문제였어야 되는데 여기서 이제 등차수열이 된다고 좀 이제 되는 걸 이제 학생들이 좀 알아챌 수 있게 만들어가지고 그러니까 메이크에는 어긋나는 것 같지만 그 등차수열이 되는지에 대한 저걸 이제 가설이라고 생각하고 그걸 이제 그 이유를 이야기해 보아라는 것을 보고 이제 그 등차수열이 되는 이유를 조사해 보는 그런 문제라고 봤습니다.
But you should understand the mathematical conjecture meaning. Okay, conjecture meaning is not kind of complete argument or proof. Okay, just as I emphasized, kind of part of reasoning and proof. Okay, that's why the inductive reasoning, for instance, the representative of this category problem is like this: n equal to 1, n equal to 2, n equal to 3. After showing several cases, you may ask, what about 100 case? What kind of pattern or what kind of number you should get? In the case of 100, in the case of 1,000, or that is the kind of investigative mathematical conjecture. As I emphasized, you need to take a look at my explanation in the category. The second category is like this: informed guessing. Do you understand what is informed guessing, right? After showing some cases, 1, 2, 3, 4, or just in other some similar cases, you may ask other information. For instance, n equal to 100, n equal to 1,000, or based on some fact, you may ask a different kind of reasoning. This is the kind of low level of reasoning. Why is that? Because you informed something, right? But mathematical proof and reasoning, you need to newly develop, right? For instance, justify or prove something. You have no idea, right? Because you only know the statement. However, informed reasoning means you need to already let student know something, like n equal to 1, n equal to 2, n equal to 3, or some, just a basic fact, and then they need to reason based on those facts. Therefore, this is the low level compared to the third level. Okay? Do you understand? 제가 지금 말하는 의미 이해하겠죠? conjecture는 informed guessing이에요. informed guessing. informed guessing 뭐냐면 수학적인 어떤 사실들을 좀 주고 나서 이렇게 생각해봐라는 거예요. 그죠? 그것과 아예 처음부터 바닥부터 아무것도 없는 상태에서 수학적인 사고를 만드는 거는 차이가 있다는 거예요. 그게 NSTM 스탠다드 포인트예요. 이해하겠죠? 그래서 뭐예요? 세컨드 레벨은 뭐예요? informed guessing, informed guessing. 디퍼런스를 알겠죠? 한마디로 말 이거예요. In Korean, I just want to clarify, okay? I already explained in English, that's why I'm using Korean. 두 가지 리즈닝이 있는데 두 개의 차이가 있어. 한 가지는 뭐예요? 어떤 걸 주고 그걸 바탕으로 생각해라는 것과 아무것도 주지 않고 생각해라는 것은 큰 차이가 있다는 거. 어느 게 더 낮은 레벨일 것 같아요? 당연히 좀 주고 케이스를 좀 주고 사고해라는 게 훨씬 더 낮은 레벨이고요. 아무것도 주지 않는 상태에 정당화하고 그죠? 아규먼트를 하고 프로브를 해라는 게 훨씬 더 어려운 레벨이라는 거예요. 그 차이점을 아시겠죠? 이해하시겠죠? 그래서 그걸 구분할 줄 알아야 된다는 거예요. 그러니까 여러분들이 mathematical essay problem을 만들 때 좀 더 쉽게 만들고 싶다. 그럼 뭐예요? 케이스를 주거나 어떤 예제를 주는 게 훨씬 더 쉽다라는 거예요. 그렇지 않고 바로 증명해라 이거는 훨씬 더 어렵다라는 거예요. 그 하이어라키 레벨을 언더스탠드 하고 나면 티처로서 또 문제 만드는 사람으로서 훨씬 더 많은 유용성을 얻을 수가 있다는 거예요. 그래서 지금 엠퍼사이즈 하고 있는 거예요. 오케이. 자 그러면은 이제 중요한 이슈는 뭐예요? 그룹 1앤 3예요. 당연히 그룹 3의 의견을 먼저 들어보죠. 왜냐하면 그룹 3는 1이라고 했으니까. 그리고 그룹 3번을 선택한 사람들 의견을 듣고 우리가 디스커션 하는 거죠. 자, 그룹 3. Yes. Why don't you tell us your opinion about this problem?
저희는 이 문제에서 그 이유를 이야기해 보아라 좀
예.
그러니까 1번 선택한 이유는 그 문제를 바탕으로 리스닝이나 프로프가 수학의 펀더멘탈한 층을 된다는 걸 인식을 해야 되는데 이 문제를 풀 때 학생들이 저는 기본적으로는 아마 얘네 1이나 2나 3을 집어넣어 보면서 시열의 일부를 만들어서 그게 등차수열이 된다는 것을 파악을 할 수 있을 텐데 그것만으로는 부족하다는 걸 알아야 한다는 거죠. 그래서 학생들은 이것을 증명하기 위해서 구체적으로는 AN 플러스 1, AN은 뺀 값이 일정하다라는 사실을 보임으로써 증명을 정확하게 해야 하고 추론과 증명을 이용해야 하고 그것으로부터 그 어떤 추론이나 증명이 수학이 꼭 필요한 측면이라는 근본적인 사실을 알 수 있다고 생각합니다.
그럼 그 이유를 이야기해봐라는 건 어떤 예를 들어서 만약 이 문제를 줬어요 학생들에게. I'm just asking, precisely. So what kind of response? For instance, as a teacher, right? You should expect what kind of response should be 100 point out of 100, right? So what kind of response can you expect? Just based on your experience. If you are going to grade this problem, what answer should get 100 point out of 100?
방금
이야기해봐라. 그럼 what kind of answer you can expect?
앞에서 저희 등차수의 정의를 배웠단 말이에요. 거기서 이제 정의하는 방법 정말 좀 다르겠지만 일정한 수를 더해서 만들어서 수열에서 할 수 있는 거고 저 정의하지만 어쨌든 등차수열은 P형의 답합을 뺀 값이 항상 일정해야 한다는 것이란 말이에요. 모든 자연자연에 대해서 그러면은 그것이 모든 자연자연을 설명한다는 사실을 그 앞에서 AN 플러스 1에서 AN을 뺀 값이 일정하다는 사실을 보임으로써 그 등차수열이 된다고 이야기를 해야지 좀 전체적으로 볼 수 있을 것 같아요.
For instance, then, if I'm going to write down this way, for instance, an plus 1 minus an equals
계산을 해서 그 계산을 하면 정확히 3이 나올 거거든요. 그 사실을 보여서 P형의 답합을 뺀 그것이 공차가 뺀 값이 일정하다는 사실을 이용을 해서 그게 등차수열 정의니까요. 그러니까 등차수열 된다고 이야기를 해야 하는
Okay, let's move to the next level of discussion then. So why don't you tell us who selected number 3? 오신아 학생. 예, 한 번도 안 한 것 같은데. Why did you select number 3? What do you think?
저도 사실은 이베로비나 이베로이드 측면이 없다고 생각하지 않아요. 문제에서 저희 조가 집중했던 것은 그 문제를 풀음으로써 수학에서 리스닝과 프로프가 꼭 필요하다는 사실을 느껴야 한다는 게 사실 1번의 핵심인데 그런 의미에서 아까 교수님이 이야기했듯이 2나 2를 더해서 4가 되는 게 4가 짝수니까 짝수가 더해서 짝수가 된다고 이야기하는 것이 잘못됐다는 학생들이 느끼려는 그런 상황과 비슷하게 n에 적당히 어떤 단수 몇 개를 집어 넣어서 이게 등차수열이 된다고 이야기하는 것보다는 그렇게 말하는 건 부족하다는 사실 학생들이 알 수 있다고 생각할 때 이 문제를 풀고 그래서 저는 1번 이 문제가 학생들에게 1번을 좀 더 강조하고 있다고 생각합니다.
You understand his point? Okay, let's hear one more student opinion. Group number 3. What is it? 정문이 발표했니? 정문아? 정문이 발표했어요?
아니요.
안 했어요? 그럼 정문이 안
저도 이제 등차수열이 이제 된다는 얘기가 없고 되는지 안 되는지 먼저 얘기를 하고 나서 그 이유를 설명하라고 했기 때문에
예.
안 될 수도 있는 등차수열이 아닌 수열을 주고 그렇게 낼 수도 있잖아요. 다시 평가할 때. 그렇다면 이 학생이 이제 되는지 안 되는지 먼저 자기 스스로 그 주장 이제 판단해 보고 나서 평가를 하는 방법이 있겠죠. 뭐 숫자를 몇 가지 넣은다든가 해서 자기 나름대로의 판단을 하고 증명을 해 나가야 된다는 그런 입장에서 저는 그 주장을 먼저 검증하는 과정이 필요하기 때문에
예.
3번이라고 생각을 해요.
반드시 그 검증하는 과정이 필요하다. 그 이유를 말해보시오라고 했을 때 3번에 더 가깝지 않냐는 측면에 대해서 어떻게 생각해요? As I emphasized many times, correct or incorrect is not an important issue to me, at least. I hope based on this discussion, you develop your own thinking in depth. Okay? Oh, let's take a look at this situation, but maybe this way, that way. A lot of different kind of approach are possible, right? And then you can develop your thinking in depth. That's my main purpose. Okay? But you need to take a look at different perspectives simultaneously, and then you need to defend yourself. Okay, that is the part of the process. In deepen your thinking process. What do you think? So basically, Jungwon talk about, in this problem, they need to justify, they need to develop their own arguments or their own proof, at least in this problem. Therefore, it should be categorized into the third one.
맞는 말이라고 생각해요. 맞는 말인데
예.
아까도 말했듯이 저희는 이게 사실 저 문제가 1번의 성공을 띄고 있는 건 아니잖아요. 어떤 해석하는 방법에 따라서 2번이 성공을 띄고 있는 건데 저희가 집중했던 게 사실 1번에 관련된 내용이라서 이것도 1번으로
Here is my result. Okay? Here is my thinking. It can be categorized 1 or 3. But depending on what kind of expectation, for instance, that's why I'm asking you what kind of expectation 그 이유를 이야기해 보아라 라는 거에 what kind of expectation do you have? For instance, which justification can get the full credit? That's the most important thing, I think, from my perspective. For instance, as you can say, kind of informally, if this is get the full credit, I don't think this is part of proof or part of argument. Okay, this is not deep or part of argument. Okay. Therefore, depending on what kind of justification, what kind of argument, for instance, if you are going to want a formal proof, more specifically, okay, that's going to be categorized. This one is third one. That's why I don't think that this statement is not good one. 그 이유를 이야기해 보아라. Very ambiguous term. Do you agree with that? You need to specifically ask the question. That's going to be better. Informal question or formal question. Okay? You really want your student to prove formally, then you need to specifically ask. 증명하시오. Right? 단순하게 이유를 말해라. I understand that because this is formally asked. The question. 그 이유를 이야기해 보아라. 이야기해 보아라는 말은 무슨 말이에요? 느낌상 막 formally 증명할 필요는 없다는 뉘앙스가 생긴단 말이에요. 그죠? 이해하겠죠? 그래서 아마 그룹들이는 그죠? 원으로 했던 것 같고요. 그러니까 우리가 뭐 어떤 사람한테 뭐 이야기해봐라 하면 느낌이 어때요? 경직되고 이런 느낌 없잖아요. You don't have to react strictly, right? You just react. 내 생각은 이래. My thinking, or blah 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 blah, right? You don't have to 막 긴장하면서 말할 필요는 없잖아요, 그죠? 이해하겠죠? 예를 들어서 정문아, 너 어제 무슨 일 있었니 이야기해봐. 네가 막 긴장하지는 않잖아. 그냥 대충 그냥 난 이런 일이 있었어. 그럼 요 문제에 대해서 What do you think about this problem? 그냥 너 생각을 이야기해봐. 그러면 뭐 느낌이 어때요? 뭐 이럴 수도 있고 저럴 수도 있는 거 아니에요? 라는 어떤 그런 뉘앙스잖아요. 그래서 제가 보기에는 질문 자체가 좀 애매모호하게 이루어진 것 같아요. 그래서 제가 말씀드렸듯이 만약에 in this problem set에서 specifically 만약에 formal argument, formal proof을 원한다면 그렇게 구체적으로 물어줘야 된다는 거예요. 그러면은 이게 세 번째 캐테고리가 될 것 같고요. 그죠? 그냥 아까 말한 것처럼 그냥 자기 어떤 rational, fundamental, 이런 게 정당성이 필요하구나 이 정도의 expectation을 갖고 있다라면은 first category도 또 될 수도 있는 거죠. 이해하겠죠, 그죠? 그래서 이 정도로 정리하면 좋을 것 같아요. Any question? Therefore, even though the same problem, what kind of question you ask is very important. Okay? Make sense to you? Therefore, if you want to develop mathematical essay problem, you need to carefully look at what kind of question you are asking. This question is appropriate, or this question specifically asks what we want from this problem. That kind of perspective should be considered. Okay, while you're developing your problem set. Make sense to you? The same context, the same problem, but what kind of question asked is very important in order to categorize any problem. That makes sense to you, right? Like this problem, even though the same condition, if you are going to ask more specifically, formal proof, formal argument, you need to specifically ask that kind of question. Okay? Any question?